All right, welcome back. I am Dr. Boyd, the chemist, and today we're gonna make it rain. All right, that is our topic. We're gonna make some rain. And what you'll need is listed here. You'll need some ice, like a few ice cubes. You'll need some hot water, and you'll need 2 cups, transparent cups, because you want to be able to see your rain. So we're gonna use 2 transparent cups. If you do not have transparent cups or glasses like that, you actually can use a jar with a lid on it, a metallic lid preferably. All right. So if you don't have 2 cups, 2 transparent cups that have the same size mouth on them, then you could use a jar like this jar here. Make sure your jar has a cap or a lid to it. All right. So again, we're gonna make it rain today. You need ice, you need hot water, and you need 2 cups. And we'll get started in about 2 minutes. Alrighty, welcome back. And again, before we get started, just want to tell you that all the videos that we have done, all the lessons that we have gone through for the first month, that's 4 weeks, lessons 1 through 20, they are all posted to my YouTube channel. And you can perhaps you go view some of the lessons that you missed if you missed any, or you can review some of the lessons that you did if you were present. And they're all posted there the full length of time that we have run these videos. So the lessons from this week I will post on Monday morning. All right, I'll post those on Monday morning. My YouTube channel, you can find me by going to youtube.com/c/Dr. Boyd the Chemist. And Doctor is DR, so Dr. Boyd the Chemist. And so that's where you can find those videos. Definitely subscribe to the channel, let people know. And there's lessons there for people to learn from and to enjoy. All right, today is a special day on the calendar. It is Earth Day. All right, it is Earth Day. And in fact, this year is the 50th anniversary of Earth Day. So it was the first time 50 years ago that Earth Day was a celebration. And on Earth Day, we do lots of really nice things typically for the planet. Now, we should be doing many of these things every day, but we at least discuss it and highlight it on this day, each year on this particular date. So it's April 22nd, 2020, and it's been 50 years since Earth Year has been an institution. And some of the things that people do on Earth Day historically include planting trees, planting plants, having discussions like we're going to have today about the value of recycling, reducing waste, reusing things that we can reuse so that we don't create more waste. All right. So Earth Day is a really important day and it's quite a celebration. And in fact, I'm a member of the American Chemical Society and also known as ACS. And ACS has expanded Earth Day from just a single day to what they call Chemist Celebrate Earth Week. So this entire week for the American Chemical Society is a celebration of the planet and trying to do the things that will help sustain the planet and keep the planet healthy. All right. And one, if there's any side effect of this lockdown and of this virus that people can look at and say, well, that's a pretty neat thing to happen, it's the fact that because people are not driving their cars so much now, that pollution has decreased. And I can tell you, I did go to the grocery store and I was driving back, and places where I would typically see lots of trash along the sides of the road don't have trash along the sides of the road because I assume or presume that people who typically would be walking to the bus stop or walking in and out of a restaurant or a store are not doing that anymore and not leaving trash that they might just toss on the ground. So that is a good thing. All right, so the earth is breathing right now on today's Earth Day. We are going to talk about a very important aspect of the planet called the water cycle. The water cycle. All right, so we're talking about the water cycle. What does that mean to you? When I say the water cycle, do you have any idea what the water cycle is? All right. Well, I think the second week or third week of our lesson, maybe lesson 15, we made a cloud in a jar. And so some of the things I will discuss today will be a bit of a review, but keep in mind, and let me just say, I hope you have your lab notebook and I hope you're taking notes. I hope you're writing things down. I've written plenty down already in preparation for today's lesson. So I hope that you're paying attention and I hope you're writing things down. Our topic is making it rain, but the focus will be the water cycle. I guess our experiment will be making it rain. Our topic will be the water cycle. Let's do it that way. So for a topic, write down the water cycle. And for our experiment, you can write down make it rain. So the water cycle is an essential part of the planet, for life on this planet. We need water. We need water to live and to survive. That's people need water, animals need water, plants need water in order to live and to survive. And the planet, the surface of the planet is covered mostly by water, not land. Now, human beings are land creatures, so we live on the land. That's what we're most used to. We don't live in the water. We can swim and we can make boats to go on top of the water, and we can make, I mentioned scuba diving gear yesterday to go underneath the water for a space of time. And then there are submarines that can be underneath the water for a certain space of time. But we live on the land. But we need that water. We need it. And the water cycle process involves water in the various phases as it goes through the atmosphere and then back onto the ground, okay? So a major portion of the water cycle actually has to do with the sun, all right? The sun provides heat to the planet. You know that, right? The sun provides heat to the planet, okay? And again, if you're taking notes, the sun provides heat to the planet. But what happens when you heat up water? Do you have any idea what happens when you heat up water? All right, when you heat up water, it evaporates. Now remember, we commonly call water H2O. Some people use that interchangeably, but believe it or not, H2O doesn't only refer to water, but it also refers to ice, right? Ice is made up of H2O. Water is made up of H2O, and then there's a third phase called the gas phase or water vapor, which is made up of H2O. And again, we've discussed the three states of matter, three common states of matter. Solids, that would be ice, liquids, that would be water, and gas, that would be water vapor. Those are examples of those three states of matter. The sun comes in and it heats up the surface of the planet, that is the ground, as well as the oceans, the lakes, the rivers, the seas, the streams, the ponds. All that water gets heated up by the sun. And when the sun heats up that water enough, that water begins to evaporate. All right. Hey, niece, nephews, I see you. Good to see you. Hope you have fun with this. Hope you're able to do this with us today. It was my niece's 11th birthday yesterday. All right. So she is 11 years old now. So happy birthday, Laurelyn. And she's featured in a video on my YouTube channel along with her brother, Tony. And I hope you all checked it out. And Tony's birthday was 3 weeks ago. He turned 10. All right. So happy birthday. Glad you could join us. So when the sun comes in and heats up the surface of the planet, heats up all these bodies of water, that water begins to evaporate. All right, when it evaporates, it goes from the liquid phase of water into the gas state of water vapor. So that water vapor goes up into the atmosphere through a process that we call evaporation. All right, now I've written down 3 portions of the water cycle here on the board just to save time. So write down the first part is evaporation. Evaporation. I hope everyone can see that. Evaporation. That is what happens when the sun heats up the water. Process is called evaporation. All right, and that's next to number 1 here. Evaporation. All right. Hope you got that. So this process of evaporation means that the water vapor is now up in the air in the atmosphere. And what happens to it? Well, once it gets up into the atmosphere, it does something else. It condenses, all right, through a process we call condensation. Condensation, all right, and you might have saw that word here too, all right, condensation. So water is heated up by the sun and it goes up into the atmosphere as water vapor through a process called evaporation. When it goes up into the atmosphere through this process called evaporation, it then begins to condense as it cools in the upper regions of the atmosphere through a process called condensation. Condensation. So the further up you go, the colder the air will be. All right. So this water vapor, which was really hot, it begins to condense through a process called condensation. All right. Now that process of condensation means that now you got little water droplets, or if it's really cold, you have ice crystals. Okay, so you can have these water droplets in the atmosphere, you can have ice crystals in the atmosphere. Now you may recall when we made our cloud in a jar, I mentioned in order for a cloud to form, the water vapor has to come in contact with dust particles in the atmosphere. All right, when a dust particle and water vapor, they get together in the atmosphere, this forms clouds. All right, we get clouds from the combining of the water droplets in the atmosphere or the ice crystals in the atmosphere with dust that are in the atmosphere. When those get together, you begin to form clouds. Now, what happens is with time, a cloud may get bigger and bigger and bigger and bigger and bigger and bigger. And sometimes they can get really big. And what happens after that is they become too heavy. The amount of liquid or ice crystals becomes too heavy for that cloud to hold all that moisture together. All right, the amount of moisture there is just too heavy. And so then something else happens when it becomes too heavy. What do you think happens when a cloud is full of moisture and there's too much moisture in the cloud for the cloud to hold it any longer? What happens? That's right. It rains or it snows. Okay, it rains or it snows. Now there's a word for rain and snow. It covers rain and it covers snow. There's this word. It begins with the letter P. Do you know what that word is? You might hear the weatherman talk about it on a rainy day. Okay? It's called precipitation. And that's a big word, so I'll leave that up. That's number 3 on my board here. Precipitation. Precipitation. All right, so we have three processes. The sun comes in and heats up the water that's on the surface of the planet. And that process causes the water to evaporate. That process is called evaporation. That's number one on my board here. All right. Then that water vapor, once it gets up into the atmosphere, it condenses. It gets cooler and forms water crystals, ice crystals, or little water droplets. And that process is called condensation. Condensation. Now, when that condensation in the atmosphere comes in contact with dust in the atmosphere, it forms a cloud. Once it forms that cloud, it can become so heavy with moisture that the cloud can no longer hold all the moisture. So that moisture comes down from the cloud to the ground in a process called precipitation. Precipitation. All right? So these are three major processes in what we call the water cycle. So what happens once the precipitation gets to the ground? Where does it go? It goes into the ground and it helps support all the life on the ground, like the trees, the roots of all the trees and the plants that we discussed a couple weeks ago also. They now have water and moisture. We, human beings, animals, we have water that is collected in rivers, lakes, and streams. And then the oceans and the seas also get replenished with water. All right. So then what happens? Now the water has come from the cloud and it's gone into the ground and it's gone into the oceans. What happens to the water at that point? We called it a water cycle because the process starts over again. The sun then comes back in and heats up the surface of the planet, including all the oceans, lakes, rivers, streams, seas, ponds. All of those things now get reheated again, and then the water goes back up. And then it condenses again, and then clouds form, and it comes back down as precipitation. And then it goes to the ground, and it goes into all the bodies of water, and the sun comes back in again, and heats it up, and it goes back up. And the process repeats itself. That's why we call it a cycle. All right, so this is the water cycle. Now, let us get into our experiment for the day. And again, I hope you really, really pay attention to Earth Day. It happens every year, something that's very important. We should really be focusing on doing things like recycling. We should be using less things that are waste. We should be using things that can be reused. And we should reduce the amount of waste that we have on a daily basis. All right, so you hear this term, the 3 R's: reduce, reuse, and recycle. And that's definitely something that we should be paying attention to. And Earth Day is a time where we can actually focus on doing that. All right, I have boiled some water. You don't necessarily have to boil it. I've learned that the water that comes out of the faucet can be very hot if you turn up to your highest setting. In fact, I measured the temperature of my water, and it's pretty hot when you turn it all the way up. So you don't need to boil the water as I have done today, but I boiled some water. What I'm going to do is I'm going to take water, put it in this cup, and fill it maybe about halfway with this really, really hot water. All right. Then what I'm going to do is I'm going to take this empty cup here that has the same size mouth as the other cup, place it on top, and I'm going to put ice here in the top of the cup. Now, if you have a really flat bottomed cup, it may be a little difficult to keep the ice in there. My cup fortunately has a bit of a rim around it, so it should protect it. Now, if you don't have cups, I mentioned before, you can use a jar like we did to make the cloud, and the same thing can happen. You fill it up halfway with some really hot water, take your cap, turn it upside down, put your ice in it, and let it sit on top here, all right? And we will watch what happens. All right, so pardon me as I go get some water. Hot water. Okay, I've got my water here. Now I'm gonna go grab my ice. Now for people using a jar, I cheated a little bit. I took my cap and put it in the freezer. So it got really, really cold. Now, all I'm going to do is I'm going to take this cup and I'm going to place it on top of this cup here. And I hope everyone can see that. I can already see the steam is going up to the top of the cup. I can see that on the inside. And I'm not sure if that really picks up well on camera, but I can see it. And hopefully, if you're following along at home, you can see that too. And what we're going to do is we're just going to observe what happens. I'm going to try this in a jar too, just for the folks who might not have cups. I can already see something happening. That is the inside of the cup on top is becoming a bit hazy, right? I hope you all can see that. This lid I mentioned before, kind of like when we made the cloud in a jar a couple weeks ago. I have this cap turned upside down. So that the ice can sit in it without going anywhere. All right. And the same thing is happening in the jar. So again, I can see in this cup that the inside of the cup is becoming hazy. And then inside of this jar is also becoming pretty hazy. Now, I hope you're taking notes. What do you think is happening here? When I say take notes, one, you should be writing down what you're seeing, your observations. That is a critical aspect of being a researcher is observing what's happening and taking notes on what you're observing. All right. So what is occurring here? What is really going on? Remember what I said the water cycle does. So if you can recall, these things are happening here. The first thing that's happening is I have really hot water. Well, if the water is really hot, it will begin to evaporate. Now, I saw the steam coming up. That suggests to me that it's evaporating. All right, that was the first part of the process. Second part of the process was what? Do you recall? Is it in your notes? Hopefully it is. Condensation. So condensation is occurring. All right. And with condensation occurring, what that means is that water vapor that evaporated away in the gas state is now returning to a liquid state. Okay, and that's what you're seeing around the edge here. That's what you're seeing around the edge of this cup, why it is like has this frosty color to it. And you know, I probably, in retrospect, I probably should have taken this cup here and put it in the refrigerator also, kind of like I did with this cap. But what I'm starting to see happen now is on the inside of the jar in particular, I'm really seeing this pretty well, but also on this bottom cup here, I can see that there is droplets of water now on the inside of the cup. Now keep in mind, this top cup especially, I never put water in this top cup. All right, so the fact that I'm starting to see droplets suggests to me that that water must have come from the water vapor at the bottom of the cup that's on the bottom holding the water. All right, same thing with this jar of water here. I never put water on the cup, on the lid here, but I'm starting to see around the top of the lid that there's water droplets forming. All right, now remember our topic today is the water cycle, and our experiment we're calling it Make It Rain. Okay, so what we're witnessing now is part 2 of the water cycle. That is the condensation portion. So what we're waiting on, and this may take a while, what we're waiting on is part 3, the precipitation part. All right, the part where the water becomes too heavy to be held up in the air by clouds, or in our case, by the lids or the tops of our containers. All right. Looks like the jar is doing this a little faster than my cup. This cup here is probably, in retrospect, and this is just part of the scientific process, you do an experiment and it might work, but there may be ways it could work better. There is a large distance from the bottom of this cup here, where the water line is, to the top. And so, unless this water is incredibly hot, it is unlikely that it will form water droplets in this cup very fast. All right, so that's what's happening. That's why it's taking so long. So, what I could have done differently is to use a smaller cup to cover this one up. All right, or use some kind of cover, just a flat cover on the top of the bottom cup, so that that steam would get there faster, or that water vapor would get there faster and then condense faster. All right. So what I'm going to do, because we only have a couple more minutes, I don't want to hold you too long. I'm going to try to boil some water really quickly to get the water to be incredibly hot, and then we'll see if it condenses fast enough. So pardon me as I go try to boil some water very quickly. While I'm waiting on that, I will give you one other fun fact. There is a process by which frozen H2O, we might call it snow, for example. Snow, when snow is on the ground, in some areas of the planet where it's incredibly cold, the snow actually goes immediately from that solid snow state into the water vapor state or the gaseous state. It skips over the liquid phase. All right. And that does happen. There's a big word for that. Do you know what that word is? It's rarely used unless you're dealing in certain fields like meteorology. And I use it sometimes to describe what I see in the laboratory. There's a word called sublimation. I'll write that down too. Sublimation. That means you go immediately from a solid into a gas, skipping the water state. Normally we see liquids, we see a solid melt, and then once it melts, it turns into a liquid, and then it goes from liquid to gas if you keep heating it. But sometimes things sublime, or they go through a process called sublimation. There's something that we use often in research that goes through this process of sublimation. If you've ever seen it before, you know what I'm talking about. That is dry ice. Dry ice, actually, we call it dry because it never goes, at least at temperatures that we would use and pressures that we would use, it goes immediately from the solid state into the gas state. All right. So we call it dry because it's never wet, no liquid state. All right. So that's that last word down there. Sublimation. Sublimation. All right. That's the process of going from snow, for example, like way at the top of mountains, this kind of thing happens. It goes from snow right into a gas state instead of ever melting. All right, I think my water's pretty hot, so I'm gonna take this one. No, don't do that. All right, I'm gonna take that down. Oh, I can see on the inside of here though, there is definitely water droplets on the top of that container. I can see it now. My water, I poured it in here, and this is just so you know, it was a little too hot. Began to melt my plastic, so next time I might do this only in a container that is glass. Thought that might happen. It wasn't something I hadn't anticipated, but all right. So I have some really hot water in there now. And what should happen, and we'll stick around for a couple more minutes before I sign off because I don't want to eat up too much of your time today. And I also have to get back to work. But what is happening is now I've got this really hot water in here. At the top of my cup, I can already see from the last batch of water that was in there that there is definitely condensation at the top. And what will happen, the make it rain part, what should happen is that the the water will build up on the top, and then you'll start to get drops coming down from the top on the inside of this cup, drop right down into the bottom. All right. So I'll give it like another few seconds. And what I would tell you you can do is you can let this run for a little while, or you can just take your ice off and look to see if there's in fact condensation there. And you will definitely see some if you have hot enough water and if your top is cool enough. What I will do in a moment is take the lid off of here, and I will show you what's on the inside of it. It's just a few more seconds, and then we'll finish up here for today. Now, with this hotter water, I can see there are a lot. The droplets are getting larger on the inside of this cup. So I hope you're able to do this. I hope you're able to see it too. I can see it where I'm at, and I hope if you're following along, you're having the same kind of success. One thing you can see down here at the bottom, there's lots of really large droplets, but also up here, I'm starting to see larger and larger and larger and larger droplets of water forming. Yeah. Big time. Big time. Yeah, so it's going to rain. This is actually going to work here. Now, I can see the droplets on the inside of here are getting so big that in a few minutes, it will definitely, at least one drop of water is probably going to fall down from the center back into the water. And that will be the success of this experiment, making it rain. All right. So with that, I'm hoping that you were able to follow along. I'm sorry that we didn't get to see a droplet drop in. It may take a couple more minutes for that to happen. But what I'm hoping is that you now have a sense of what the water cycle is, its importance to the planet and to every living thing, and that you now know what the process is. All right, we have evaporation because the heating of the ground from the sun. We have condensation once that water vapor gets up into the atmosphere. We have precipitation when moisture in the atmosphere combines with dust to form clouds, and the clouds become too heavy to hold the moisture, and it comes back down to the planet. And then when it comes back to the planet, the cycle repeats as that water that came down as precipitation now goes back into the lakes, rivers, streams, oceans, and seas. All right. So with that, I just want to say thank you for joining me today. Again, you can check me out on Instagram at sciencemadesimple_LLC. Or you can subscribe to my YouTube channel at Dr. Boyd the Chemist. Okay? All right. Thank you all. I hope you enjoyed this. Hope you're able to get it to work. And I will show you the inside of this before I get going. Oh, there's lots of water there. You can see, yeah, there's a lot of water. All right, so a lot of water just spilled off of there. Okay, so I hope you enjoyed this, and I will see you tomorrow at 2 p.m. Eastern Time. Take care.